Hello, this lecture will be given by Mr. Petr Svoboda, founder and CEO of Stratox Cloud Native company. Stratox is developing product CodeNOW, which is software factory as a service.
Hey, hello everyone. When I'm talking about software factory, I'm actually talking about application platform as a service. I'm not gonna go into detail what the difference between infrastructure as a service, platform as a service, software as a service is. I assume that most of you is familiar with it anyway. There is just one thing, and that is that application development is one particular area that we will be talking about. Gartner also is speaking about that as a value delivery stream platform. Basically, it is about unifying the workflow from the developer perspective so that the whole DevOps infinity loop is integrated into single self-service experience. Basically, that's the goal. Because when you are creating software, A, you are not alone, and B, in a larger organization, there is a lot of handovers, and I will talk about that. So Software Factory is trying to solve this problem. So why to use Software Factory? I will be explaining for the rest of the presentation mostly. Just for the reference, most of the experience I have is coming from enterprise organizations where there is typically something about, let's say, 800 plus developers, infrastructure people, operations people, analytical tests. So these teams are rather large. Typical enterprise organization is starting roughly 150 IT projects every year. When we are talking about onboarding and the project ramp up periods, this is the penalty that actually is being paid 150 times. And just because of usual churn or rotation of people provided by contractor agencies, some 120 people come and go every year. So from the learning or teaching perspective, this is the volume that has to be handled by the organization. If I will take a look on the whole market, not just at a single enterprise, these are numbers from some Stripe research, which was conducted in 2018. So it's a bit obsolete nowadays. The figures will be a bit higher, I would say, at this time, but you can take a look at the generally 18 million developers out there with some average salary 51k USD comes to some $900 billion every year being paid. It is also being said that roughly 30% of all the developer productivity or efficiency is lost every year. Most of that is due to waiting and handovers between the teams, or due to mitigation of technical debt, or due to maintenance of poorly written software, or maintenance of a software that requires a lot of manual maintenance. That's the source of this efficiency loss. Automation to the rescue. So generally the market that is being tackled by these figures is roughly $300 billion yearly. Cloud native and microservices is the way how to move forward nowadays. I'm not gonna talk about, or maybe later on, bit why. Generally, everyone is looking for agile development, for rather, I would say, customer-centric development, or product kind of approach to development, where all of that requires a lot of interaction between the business people, UX people, developers, architects, and the operational or site reliability engineers. So microservices is something that from the architectural standpoint brings the possibility to achieve this agility. Cloud native, on the other hand, is, and I will talk about that, is some, let's say, set of characteristics that are embedded into the software and into the way how the software is being operated and delivered. Unfortunately, this combo creates quite a vast and complicated stack. So you have infrastructure problems that are in many cases, I would say, quite proprietary. If you think about Microsoft Azure, then about AWS, then about GCP, and you are looking for a way how to automate stuff over these platforms, then the developer that is facing the issue has to be quite knowledgeable. There are, of course, platforms that are trying to tackle this problem. We are creating one of them, and generally Software Factory is the place, or value delivery stream platform is the place where this problem should be tackled actually. Why? Because if you will not do that, you will end up with a fragmented workflow. You will have a people that are knowledgeable in Ansible, in Terraform, in Salt, or whatever kind of infra automation tooling. You will have another people who are, let's say, knowledgeable in how to operate the productional deployment, or some other people that are reliable for infrastructure provisioning. So if you need to create a new database instance or new cluster for Kubernetes or something, you as the developer will end up waiting and waiting, because how does the workflow actually look? So you want to start developing. So you need some, let's say, Kubernetes namespace. If you don't have a right to actually provision that namespace by yourself, you have to order that in some workflow system and you wait until you get it. In the meanwhile, you can play on your notebook, but in a lot of organizations, you just don't have enough rights to play with that on your notebook because you do not have administrative rights on your notebook. You can resort to some kind of virtualization, but let's not get into too much detail. Then you will get the namespace or the cluster, so you can provision some container somewhere, fine. But then you need what? You need a message broker, you need database, you need some observability tools, etc. At the end of the day, in typical enterprise, you will end up waiting for weeks before you will receive all of the things you need to be properly developing. That is causing problem called business value creation, or delay of the business value creation is the problem, because the developer is not there to wait, and on the other hand, developer is not there to solve problems like how do I migrate this database from staging to production. Developer is there to think about business logic, how to solve problems, maybe architects, how to design stuff. You can also take a look on it from the perspective of money, and that's how a lot of companies actually end up doing so. So they will say, we can either buy something, let's say, let's go to VMware Tanzu or to Red Hat OpenShift, but all of that platforms are, I would say, quite proprietary and they create a lot of vendor locks. So they resort to custom development. For custom development, you need to know, you need to have a lot of knowledge because there is a lot of topics to solve. And therefore, at the end of the day, they will say it's so pricey and so complicated that we will rather avoid the problem and we will continue with our JEE stack that is working just fine. Yeah, from the microservice perspective, there is a lot of topics to be solved. And sometimes these topics have impact into infrastructure, sometimes into technological stack, sometimes into the way how you develop and the workflow. At the end of the day, there is a lot of things to actually know about. And if you will take a look out there into the general market, it's not really feasible to assume that, I would say, 50% of the developers out there know what this is about. Yeah, they can learn as they go, but if I'm paying them not really small salary every day, I don't want them to be learning in the time they should be already productive, because that's hindering the productivity, and at the end of the day, it's killing my budget. Some of these problems can be solved on the infrastructure layer, and some of these problems can be tackled in a, I would say, unifying way, so the developer does not have to think, how will I solve log aggregation? Or what kind of library I will be using to expose my performance metrics? Or what will be the framework that I will use for event sourcing or whatever? There is zillions of frameworks out there, and you just cannot pay with every project the penalty that someone would be finding out. So what is the nice tooling that I will use exactly with this project? Because as you remember, there's 120 projects started every year. So if I will, let's say, spend 10 man days researching on what will be the technological stack on this project, that's some 1200 man days with average man day rate 10,000 crowns, not really a cheap endeavor. Next part of the problem, so I can solve the microservice architecture, fine. Then the thing is where the microservices will be running. Okay, sure, I can, everyone will resort. So there is Kubernetes, and that's just fine enough. It's good enough if you want to play on your notebook or with a toy project. If you are in a real world deployment, then there is ton of problems that you have to solve or someone have to solve. And again, it's not the developer that should be knowledgeable on how will I provision some network, or what is the difference between object storage and block storage, and which storage I should use for this particular problem that I'm solving. And there is 16 other providers of object storages. So which one I will use? That's a lot of topics. And again, these should not be handled by the developers or architects at the time of designing the project. This should be handled by the platform. Last but not least, the technological stacks. So again, project is starting and someone will say, okay, so what will we use? I need a graph database, I need key value store, I need some messaging. So there is like 16 different providers of each of these technologies. So I will go to, I don't know, I just screen scrape some tech stacks and I will look at, this is Launch Darkly, I guess. So how Launch Darkly is doing that. And at the end of the day, I will find out that, okay, so they use Postgre as a relational store, document store, key value store, a real-time database, message streaming, and then, okay, so what is available to me? How many of these technologies do I know? How many of these technologies will rest of the team I will be part of know? How will we spread the love and spread the knowledge of this particular technological stack? Another problem. If I will come back to the development and architecture standpoint, most of the corporate and small business development is really simple. There is, I can imagine, especially in the school, there is a ton of really funny problems, actor frameworks and playing with the blockchain and AI and machine learning and all that stuff. That's really cool. But if you will go to the general market, I would say 80% of all the development fits into this pattern. You just have a front end, you have some API exposed, maybe you have some service providing some shared services, and you have a storage, and that's it. A lot of stuff will just fit into that. Of course, at the end of the day, when you think about larger problems, so let's say I was sitting in banks for past, I don't know, 12 years. I want to do a loan origination system. Yeah, there will be many services over here. But what do they do? Okay, 90% of them will just take the data from the UI and will stuff them into the database. On the way, there are few computing units, something that is executing some business rules. Okay, the business rules can be encapsulated over here and are solving typical stuff like know your customer, KYC. Does that address exist? Okay, what is that? Integration problem. So I have a business logic of all the addresses, database of all the addresses, and I'm validating, does that address exist? Does that person exist? Okay, so integration of registry of persons again fits into the schema. Maybe I can have some funky logic on actually thinking about what is your bonity, what is your credit worthiness, maybe there. But a lot of stuff just fits into the schema. That's just the facts for the beginning. Now let's take a look on what the value stream platform or software factory actually should cover. Generally, you always have a customer. It's either external or internal one. So this might be a business people that want to deliver a new mobile banking, or it might be a perspective of the mobile banking user. But let's stick to the fact that this is the business team that actually says, I want new mobile banking. And then the platform should cover plan and creation of the project, and therefore you need to actually solve some compliance and security problems. Then it should actually solve create, meaning the create of the software. When the software is created, you need to integrate and verify the consistency. Then you need to deploy it to some production, operate it, and then you get some feedback when it is overloaded and why it was actually overloaded, what caused the overload, and how come that the autoscaler actually did not trigger and did not handle that automatically. At the end, what actually comes out of that is the customer value. So continuous delivery and continuous improvement are two key concepts that actually software factory needs to solve, because continuous delivery is about delivering the value to the customer, to the end user constantly. Yes? And because nobody likes waterfall, even though waterfall is good for some types of the projects, but let's stick into the part of the world where agile and iterative kind of a development is way to go. So continuous delivery is a must, and continuous improvement, of course, because what you deliver is not exactly the best every time. So you need to improve that. So how does it look like if you don't have integrated environment? There is a lot of tools that you have for the plan phase. You can resort to, I don't know, Jira, probably everyone knows. There is a lot of other tooling where you can actually define how the software will look like and what is the backlog, etc. Then you are coding, building, and doing the configuration. Again, a lot of tooling over there. Verification, testing, a lot of tooling over there. Then you are most likely packaging into some containers. So a lot of tooling over there. Then you actually do some pre-production and you need to provision some temporal environment in which you want to actually execute system tests or user tests or something like that. Then you want to deploy something to production most likely. You need to configure the thing and you need to monitor and operate. If you take a look on this tooling to integrate all of these tools, it's really expensive. Number one, a problem is it's expensive. B, you as the one who's buying that and purchasing all of these technologies are responsible to cope with the pace of the changes that each and every vendor is actually having with their product. So each time Atlassian and Jira will create a new version, you have to find out, is it still well integrated with my whatever build tool? Do I still see the commits there or not? So that can become really problem, and at the end of the day, in most of the enterprises you will find out that there is a dedicated department that solves this kind of a problem. You have a huge identity and access management problem because your credentials are typically spread all over the world. With a small business, you have multiple identities which are not integrated. With enterprise view, you are either lucky that you can use public offerings with a single sign-on, or you're unlucky like a bank and you need to resort to on-prem, and you will find out that half of these technologies are not available in on-prem anyway, or they just cannot integrate to your obsolete Kerberos provider. So you will end up with multiple identities as well. When I'm talking about building software, something else is to build a Hello World implementation where everything is nice and shiny. And something else is if you have a 120 people team that is holding some million lines in production, and then you need a lot of, I would say, enterprise grade things like versioning, and then we come into versioning in microservice architecture can become really hell. And to try to solve this problem on a methodological approach will just not work. You can say we are following semantic versioning, everyone knows, and then if 10% of the people will just not follow, you're screwed, because you will end up paying ton of money just by actually mitigating this depth in a higher environment. Of course, you can solve this problem by automation, and that's what some continuous integration is good for. I will not talk about each and every one. You probably know about them anyway, but multi-cloud deployment and configuration in multi-cloud environment, nice problem to solve. Logging and call tracing in a distributed environment where you are spanning multiple protocols. Okay, call tracing on HTTP is cool, but then I have on the way couple of TCP protocols, and then what? Single sign-on identity permission models. Definitely, when you end up actually securing your deployment, the thing is, how is everyone doing that? And is everyone doing that in a way that it actually integrates together? Or does it actually works in a way that me as a bank, I have, I don't know, 100 teams, and 20 teams is doing it this way and 20 team is doing it another way. I definitely want Git operations because that's basically a prerequisite for any automation. Infrastructure as code, configuration as code. Definitely these days you want to actually go the way towards immutable infrastructure. So putting that all together, of course, management, some infrastructure as a service, some infrastructure services on top of that, and then some domain specific solutions that you want to reuse, and then you have that features that the software factory has to come with, or the application PaaS has to come with from the developer perspective, and then you are developing new applications on top of that. How we are actually tackling that with CodeNOW, generally there is this CI/CD stream. So yeah, it starts with Git, CI part, CD part. You need to provision your images somewhere. You want to store your artifacts somewhere. You want to describe your deployment descriptor somewhere. Once you actually build and deliver, you need to observe. So again, there is some tooling for time series data collection, time series data visualization, time series data storage, and then you need to actually solve the consolidation of the unstructured data, standard out and standard error outputs. That's done by FluentBit. Comes into logkey is logql slash some UI on log research and Jagger for end-to-end tracing. Security management, of course, you need some SSL, you need some identity and access management, you need to store your secret somewhere, platform for containerization, runtime is probably leaving Kubernetes as far as I know, so that's gonna change. Automation and configuration of the infrastructure, either on the IaaS level or on the PaaS level. Quality management, etc., etc. Maybe just to show you something, this is how it looks. So I can take a look that I have some application development, and me as a software developer, what I want to do is I want to create new application. It's application that consists of components. So let's say data store backend. And as I was talking, this is the way how we are tackling the problem of actually coping with the developer creativity. If you think that you have 1,000 developers in your organization, you don't really want to have 1,000 different Java frameworks or 200 different ways how you expose something. So there are unified technological stacks that are either language or framework oriented. And I know at this moment that when I will use Java Spring Boot, it will use the right version of Spring Boot that has solved with the vulnerability problems. It is using the whole dependency stack. So I don't know, for example, if it uses Spring Fox to expose Swagger interfaces or Swagger descriptions, it actually works, not that it fails, etc. So I can provision component like this. What it does is actually it scaffolds the component, some sort of a hello world implementation that is buildable from any moment. I can go git clone that, and the developer goes actually and there is something that I don't actually mean it anyhow bad, but within enterprise you have senior devs who are capable of actually learning by themselves everything, and then you have just, I call them average Joe. It's a nice guy who can actually solve the problem, who can actually code, integrate, do whatever, but to want them to come up with the way how, for example, the stack is built, or what plugins should I use in what versions, why should I use this library over some other library, it's just way too much. So this is the way how you can actually make their life easier, and at the same time, because they can provision the new git repo and do the scaffolding immediately, they get to coding and they start solving what they are paid for, deliver the business value, solve the business logic of the problem you are intended to solve, and they can just go and code. And I have some ready-made simple thing. The difference between this and the tutorial on the medium.com is that this will be buildable immediately. We have been doing some research that actually 70% of all tutorials that are out there, they just don't work because after typically single year they are outdated. They were written at the time the platform our author was actually talking about looked different. They were using older version of Docker, older version of AWS EC2, older version of whatever, and after a year it just doesn't work that way. So this is the way how you can actually solve the problem. And if the software factory can provide you with features like this, your developers do not have to resort to tutorials out there in the wild. In the meanwhile, I can go and I can provision my own database. And again, if I will talk about enterprise kind of development, this seems like a limited set of technologies, but basically what it gives me, I have weakly consistent database, I have strongly consistent database, I have key value store, I have transactional messaging, and I have streaming. I have some solution for identity and access management. And when talking about backend services, if I am not able to architect, as I was talking about, that most of the solutions actually fits into the schema. If I'm not able to solve this with this tooling, then maybe the problem is not with the platform, maybe the problem is somewhere else. So let's say I want to use Redis just to store some key values. I can, oh, let me switch. I will provision my new environment for myself. Let's say it's gonna be development environment. So what it does at the moment, I can take a look. The factory, it's automate, it is creating some, oh, it's already created. What it did, it actually provisioned a new Kubernetes namespace, and it actually did connect it to some logging and tracing and to service mesh and set up some basic rights. So now I have created a Kubernetes namespace for myself. I don't know where it actually runs at. I don't care whether it's Azure or whether it's Google or whether it's some on-prem cloud. From the developer perspective, I don't care. I just need a container that runs my Java thing inside. I can provision, as I said, some Redis. Now I will say it's gonna be deployable only for the CVUT environment. And because it's development, I don't want high availability with 5 nodes. I'm happy with 1 node. Okay, something is wrong. Okay, and again, it's the factory that will provision, and someone else, it's the platform team that takes care which version of Redis, how it is being deployed, how it is being configured, how it is secured from the network perspective, from the user perspective. I don't care. What's important from my perspective as a developer, I can self-service. I can do self-servicing when I need to provision that. I have suddenly managed store and my Redis instance is up and running. Well, it's not. Persistent volume claims, fine. We've ran out of, oh, no, it's, maybe we have run out of PVCs. And in the meanwhile, I see that my release pipeline, the production build, production quality build of scaffolded component is done. Someone from the platform team has created the template, the scaffolding template for all the developers that are within the enterprise. And now all the developers within the enterprise can share the knowledge and share the know-how. How do you actually do this and that, and what did you use? And if I will take a look on those 1,000 Git repos that are sitting there, most of them will look the same way. I can reuse suddenly the Sonar experience on what did you do to pass the quality gate actually, and how did you solve the problem, because there is this XML and I don't want to be doing the XML comments. That's nonsense. Okay. So this is how the software factory can actually look. So what is cloud native anyway? So now we have been talking about why do I need it? I need it because I have so many projects started and I don't want to pay the penalty that each time I will create and I will end up with a different project setup with a different technological stack. I need an environment where I can actually share knowledge and I can rotate people, because if I'm not standardizing the way, then the question is, if how do I rotate people between teams, for example, or how do I make onboarding cheaper? So that's what Software Factory can actually solve for you. Then there is a question, you are developing microservices or are you developing cloud native application? So the question is, what is cloud native? Cloud native is something that you actually leverage cloud platform services for a reliable and scalable infrastructure. That means it's not like the Netflix OSS framework has been a couple of years ago, where they tried to solve the problems of scalable infrastructure as part of the framework and part of the library set. That's not really a good idea, because you will end up with, Netflix has abandoned that for a reason, right? Because you will end up with a tremendous pressure on the developers, so they need to know so much. And instead of actually solving the business logic of what is being delivered, they are solving infrastructure problems. Cloud native application should be written in a way that it leverages what is below that application. let the platform do the hard stuff. Cloud Native should definitely use non-blocking asynchronous communication. Synchronous RPC calls are good to a certain extent, and you need to know your boundary, and you need to know the risk of scalability when introducing these RPC calls. They are good for fetches, fair enough, as long as you are fetching from some read-only replica. But to create some complex architecture based on RPC leads to fragile distributed monolith, basically. Cloud native applications should actually scale horizontally, and you should be able to add resources as the demand increases. This is partially, of course, there is autoscaler, but the autoscaler can be adding wrong resources. The question is, why is my CPU load high? Is it because the business logic actually takes so much time to execute? Or is it because my database, which is below, is just a bottleneck and I'm waiting for connection to be assigned to me? That's a question. If I'm not taking a look on the application as a whole, then this problem, you cannot solve that on a particular layer. Cloud native application scales and is able to receive new resources at each and every layer. Should actually cost optimize to run efficiently. That means that typically it's very easy if you come up with a stateless implementation of your, I don't know, let's say Edge API or something like that. It's very easy to add new containers by autoscaler. Then the question is, how do you actually downscale? And is your application able to handle the graceful shutdown? And what are you going to do with the pending HTTP connections that are modifying data, and the same person actually relies on fetching the data just one call afterwards? But if you do not know how your architecture is actually designed, how do you actually prevent the problem that the fetch will not go to different microservice, which is holding its own replica, and the data there is asynchronously replicated? Then suddenly, from the end user perspective, you might end up in a situation that he did write to a single node, and then because the downscaling was there, the node is not there anymore to provide the read. Therefore, the read will be handled by a load balancer and will hit some random replica. You have no idea what kind of data is there. Definitely should be scaling, should handle scaling events without downtime or user experience degradation. I have this sample application here. So basically, how do I achieve that? This is a seat reservation application for České dráhy, right? So I have a front end and I have a Edge API, which is not storing directly to the database, which is just inserting some message to the Kafka. Because there is a lot of legacy systems that I need to actually call to handle the reservation properly, and because I just cannot rewrite the whole logic and everything as part of a single project, because that project would take many years, I just want to introduce a thin layer of applications, and this pattern is actually called strangler pattern. By actually separating these two components with a Kafka topic, I have just enabled that this can run while this can be down. And from the team perspective, if I'm responsible that this whole thing works, this is where the public risk is. Everyone will yell at you if the reservation front end will tell you, oh, we're sorry, we have 150 concurrent users now and we cannot handle anymore. Yeah, but the train is leaving. That's wrong. So you want this to be actually as thin and as decoupled as possible, so you actually receive the reservation, and then you can handle and tackle all the problems over here completely separated from the user experience. So if there is performance degradation, it's happening most likely here or even here, not here. I hope that I'm not moving the mouse too quickly. Okay. Cloud native applications should definitely handle transient failures without user experience degradation. That means when you are running in, let's say, in public cloud, what happens basically every week that every public cloud provider has a downtime. It's not like they are up and running 100 and their availability SLA is 100%. No way. Everything is basically constantly in the shape of broken infrastructure. It's more down than up. What it means from your application perspective, you just cannot actually rely on the fact that call will finish, or that call actually, that endpoint is going to be there. And network downtime, that's application problem. On an infrastructure problem, you can solve, I don't know, let's say service registry, so you don't know what the endpoint actually is because you are calling consumer service version 2 and you don't care what IP address it has. But if in the middle of the call it fails and it gets disconnected because there is 100 millisecond TCP disconnection, your application should be handling that. And again, what can software factory do for you? It can bring a technological stack that can help the developer. You can deliver template projects how to solve these problems. Handle nodes without downtime, of course. Geographical distribution, not exactly a Czech problem, but once you will be working for international startup, you definitely will find out that you need edge services to be running as close to your user, because the network latency given by your physical constraints is just there, and at certain point in time it is a problem. Upgrades without downtime, definitely. The platform developer has to write the application, or the technological stack under the application code itself has to be written in a way so it handles graceful shutdown, or it actually communicates somehow that the shutdown is there, or what is going to be what needs to be done manually to actually enable the shutdown. But you want to be upgrading your application with rolling upgrades during the daytime. Nobody wants to do the actions like we are going to deploy to production, so let's meet in the office at the midnight and we have 4 hours before 4 a.m. to actually deploy the thing to production. No one likes that. Scaling, we have talked about that, monitoring and management. Let's take a look at this. I have this reservation application from the example. So I see I have API, business logic, and front end. And if I will take a look, I have it deployed at some environment. I see what version is deployed. I see it's healthy. I can open it in browser. So let's say I will click on the front end. This is the demo front end. Okay, I will go through Svitava train. Now I have booked my reservation. Fine. And now the developer wants to see what has actually happened. So very cool feature is the service mesh. This is some of the call graph. So I see that I actually got through ingress gateway, something like this. I got HTTP call to service endpoint, and that's running some application in version latest. Because it's a single page application, the call to API was actually originating from the browser. So this is the call to the API itself. And I see the API is deployed in version 2.1. And what it did, it stored some message to Kafka reservation topic running on some managed Kafka broker. Then I see that there is this business logic, and business logic is connected to the same topic. It saved the data to the Postgres database, and it also actually sent notification to some Kafka topic, Kafka notification. And there is, last but not least, mail sender over here, which is waiting and reading these notifications and processing. Suddenly, even if I'm a new developer on the team and there is very poor documentation, after few interactions with the system, I can learn very easily through observability tools how the system actually works, what it does. There are other features like tracing and logging, again, should be handled by platform. So if I will again make an interaction this time through API, again, auto-generated Swagger. So I have this reservation controller. Try out. I'm not gonna fill. It's very stupid. And I suddenly see very easily where is the endpoint, what was sent, how it was sent, what was the response, and the response headers. Here that there is some trace ID automatically provisioned by Istio. Well, actually Envoy proxy, which is a sidecar container to the deployment. Again, problem to be solved by the platform team. From the developer perspective, I just want to see that I have a way how to get to this ID. As a developer, I don't care the magic, how it happened. I'm not paid actually to do that. I'm paid for the reservation to be stored and solve the problems that the reservation system is up and running always. That's the problem the developer should be solving, not this. But over here, suddenly I see, okay, tracing, it called, it finished in some 100 milliseconds. That's rather large. I can see trace graph. And again, this is just a typical Jagger UI that you most likely use anyway. From the logging perspective, I have integrated logging facility. So again, me as a developer, I don't care how it happened, but somehow I see some interaction and I see there is 2 new reservations. Okay, these topics are topics that should be handled by developer on the application layer and should not be handled by developer on the infra layer. There should be platform as a service that is helping the developer with this. That's the point. Cloud platform, that's the thing that actually everyone resorts to. That's just the public cloud. This is what Azure or DigitalOcean or I don't know who is providing. I'm not gonna go into much of detail. So when I take a look on how to adopt cloud native, there is some way how to actually get there. If you are starting on a green field, of course you can start with very much advanced setup, but 2 years down the road, the setup will be obsolete anyway. So even though you think that this roadmap is not important at the moment, not this particular one, maybe not for you, but for thousands of enterprises out there, it is very much important because they are not really doing container development as a mainstream. It's still a new thing. I don't know whether I have some. Yeah, this is maybe a good slide. As Gartner is computing these hype cycles, you can see that okay, software as a service, plateau of productivity, that's fairly known, and everyone resorts to that. Infrastructure as a service, of course, private clouds, very well defined. Managed services, through of the disillusionment. Yeah, desktop as a service, definitely that there is a huge disillusionment, I would say. Container management, multi-cloud, that's exactly inflated expectations. Everyone is talking about multi-cloud, but if you take a look on what is there working and what you can actually rely on, very few things work in the enterprise grade quality. And what we are talking about nowadays, cloud native, that's not even a hype yet. The hype will happen. Now everyone is talking about it, but that's a very tiny portion of the world view that the blog posters and top-notch technological companies from the overall market, that's just less than 1% of the overall market, I would say. So cloud native will become a mega trend 2 years from now. Okay, so how are we doing with time? I have maybe...
There's still 30 minutes left.
Okay. Okay, so just a small recap. Basically, what is the software factory good for? Well, you give developers a self-service portal. What is it good for? Definitely deliver self-service. Yeah. Mm, Developers should be able, as I showed you within CodeNOW, they should be able to do all this stuff that is needed by themselves. I want to create new components. I want to deploy them. I want to provision environment. I want to take a look on how it's working. I want to see all the pipelines. I want to provision backend components. At the end of the day, most of the time, I will end up, or I should end up, within IDEA anyway. I don't want to I just don't want to spend hours and hours finding out why this Docker Compose is working for a friend of mine and is not working for me, and what's the difference. Avoid reinventing the wheel. Definitely, if you take a look on it from the corporate perspective, there is ton of clever people who actually did invent a lot of good stuff. The problem is, do they know about each other? How do you actually handle the fact that within those 1,000 developers, 20 of them has created something really neat and you want to share that within the enterprise? Not very easy task to solve. Does their manager know? Does he understand? So platform can actually solve the problem. Reference architecture, it's about having some reference implementations for typical problems. So this is a typical problem that happens. That's a way how to move forward. So people do not have to find out how to solve problems someone else was solving before. And especially how, from the enterprise perspective, keep some sort of unification. Microservice architecture, that's a nice one. If you do microservices, so count with me. I have a solution that has let's say 20 microservices. Then I have 5 environments that solution has to go through. I have development environment, I have some staging, I have production, I have pre-production because I want to make sure that the performance tests are actually executed in pre-production. And then I have some temporal working where the hot fixes and bugs are actually simulated. So that's 5 times 20, that's 100 actually deployments suddenly. And now if you think about that, you are doing that for some multi-country solution, and not each and every microservice is actually able to handle all the multi-country problems, but you rather have multi-country deployments. A, there is some level of isolation, and B, you do not have to hard code all those ifs into the code. If Poland do this or if Germany do that, then you will suddenly end up with few hundred containers, running in production, and or not in production, running in the platform. And then the question is, okay, so I have suddenly 400 microservices out there. How many configuration items I have per microservice? How do I solve the stupid thing like here is a password to the database? Okay, how many databases and how many passwords then? So microservice architecture is actually bringing a problem on the large scale. On a small scale, to have 3 microservices, nice and easy. On the large scale, it should be the platform that is actually handling that. Reproducible dev environments, of course, what you want is that the developers can talk to each other and can come to a common ground. If everyone is having their own notebook and one is having Windows, the other one Linux, the third one macOS, plus different versions, one is running Dint, the other one is running just Docker, the other one is not, I don't know, running anything at all. How do you come up to agreement why it is not working? Automated infrastructure and continuous delivery, we have talked about it, I believe. So when to use it? When you there is a huge concept called learning organization. So when you want to achieve learning organization from the software development perspective, this is a way how to actually make it efficient, because suddenly it's not that you have 1,000 topics and the problems are fragmented over zillion ways. Because the problem of, I have been to many technological Tuesdays and application Thursdays and platform Fridays, etc. One of the problem that is always there is that the people don't go there because they are not interested in the topics that are being discussed. If you have 1,000 topics and you can just discuss one, then you have 1,000 actually meetings. That's 1,000 weeks across. You are spanning the teaching part or the evangelization part. So nobody actually goes there because, oh, they will be talking about infra automation. I don't need it because I'm just an application developer. When you go through the software factory approach, it's unifying so many different people, because suddenly they can meet on a single topic, and therefore suddenly they have a reason to go there. Reduce cost of experimentation. That's a really nice use case, because as a developer, you have some hypothesis and you want to prove it. Okay, so should I use this database or that database? Will the graph performance will be like this, and or should I actually throw it away and should I resort to some other kind of a data structure? How do you validate scaling perspective? How do you validate load perspective? How do you validate multi-threading perspective? How do you validate, I don't know what? There is so many hypotheses to be validated. If the only thing that you can actually have is your notebook, that's a pity, because then you are on your own. So then, on the other hand, if you do not have a software factory or some application PaaS within the enterprise, then you end up waiting for a couple days or weeks before that environment for your experiment is actually provisioned. Okay, build, run teams, DevOps. Yeah, that's just the typical DevOps thing. You want to have teams that actually build and run the same thing. You don't want to have one team to build the software and some other team cope with the responsibility to keep it up and running. That just doesn't work. Design thinking for a radical innovation. Again, very nice thing, because when you take a look on how customer experience actually, or how the process of service design now is service for the customer, how the process looks like, you have a lot of hypotheses there and a lot of like validations with the focus groups and with the market groups and I don't know what. The problem is that if the developer is not part of this early cycle, they will pretty much validate some Figma drawings or at best some actual prototypes, which A, deliver very limited interaction perspective, B, almost always deliver almost zero data perspective, C, they do not actually expose the hardcore problems to the teams, which are actually business problems. For example, if I'm talking about eventual consistency is not a technological problem. It is a business problem. On a technological level, you can solve eventual consistency, and there is certain level of guarantees. You probably have heard about CAP theorem, so I'm not gonna go into that, but you can solve that. The problem is on the user experience level. For example, if you are doing a mobile banking and you have just paid an invoice, and the mobile app has actually transferred you back to your home screen, and on the home screen you have your account balance. Is the payment deducted from the account balance or not? That's a question. Has it been deducted or not? Did the bank actually process the payment or not? What is the balance anyway? Is it a balance without the regular payments? Is it a balance without or with the card blockage, which is actually waiting or pending? Suddenly the topic is very difficult to solve, because there is not single thing like account balance. There's like 4 different types of account balances. Who will reconcile and who will explain to the end user that the amount is not there, not because we have not sent the payment, but because there is a 500 millisecond latency between replicating the payment hub and the mobile banking read model that is holding the copy of the data. And why is it holding copy of the data? Of course, because you want high availability and you don't want to introduce fragility that a payment hub is actually not working, because payment hub does not have to be up and running all the time, but the mobile banking has to be running all the time. So suddenly you have a problem, but it is a business problem from the customer experience design point of view. So if you have a software factory and you are able as a developer to match the speed, how quickly the design people or the UX people are moving forward, suddenly you can be a very valuable member of such design team, and suddenly the organization can deliver much better products to their customers. Gradual onboarding, yeah, that's as I was thinking. Basically, in enterprise, you have people constantly coming and leaving. And then the question is, to which team do they go? And then there is a wiki, if you are new on a project, how to actually work within the enterprise. How many of these wikis do exist? Who is maintaining them? Many of them is actually obsolete and they don't work anyway. Without this tooling, average time in one organization we have been deploying to was like 20 calendar days before the person was fully onboarded. When this approach has actually changed to application platform as a service, this onboarding time was cut down to just 5 calendar days. Maybe one more thing over here, just to show you some sample architecture, or this is CodeNOW architecture of our product. So generally how it works is that you have this self-service portal, which is this UI. You have cloud provisioner, because we support hybrid cloud deployment. This is piece of automation that actually deploys to some particular cloud provider. Then there is space where your applications are actually running. And there is some centralized, highly available monitoring cluster that is just observing everything, that everything is actually up and running. So what is application development platform as a service? It's the facility that makes all of these parts possible. We have 20 minutes for questions, so I'm happy to answer anything.
First, thanks for the presentation. Very interesting. I wanted to ask, imagine you create a small company, have an idea, and so you start with the code monolith because you want to be fast on the market, get feedback from customers, etc. But then the company grows and suddenly we have a company of 20 or 30 developers and still one monolith. And so we want to enhance processes, simplify, say, CD pipeline, or maybe offer the app as a system as a service. So what are the first steps to be done? Where to start? I don't know, let's say to decouple the app and create containers, or how to start?
Yeah, Good question. So how to start? I would take a look on it from a domain-driven design perspective. It's an open methodology. Anyone can learn it. There is a ton of documentation on how to do domain-driven design out there, a lot of examples. What's good about domain-driven design from my perspective is that it forces you to create something that is called ubiquitous language and encapsulate problems into something that is called bounded contexts. When actually going through that process, you can of course go through your monolith, existing monolith, and you will just reverse engineer the domains that are there. And basically then it will give you a nice view on how the application or the solution should be actually structured versus how it is structured at the moment. Maybe the monolithic structure is not bad at all, because monolith at the end of the day just says that you have it in a single Git repo. But even within that single, if I will take a look on trunk-based development, for example, it's a way forward. You can definitely work with it. But of course, there has to be some structure within the repo and from the software architecture perspective. So the people do not have actually edit each other's code constantly, because then you will end up in a mess of pull requests. So what I would do is I would actually go through the first step of context distillation. That means first I have to find out what the application is actually solving. How to do that? I can maybe show you some concept, some customer journeys. Basically, you say from the end customer perspective, what you are trying to achieve, some basic segmentation of the customer, some basic description of the product and service that is being used, and the channel where the journey is being executed. It may be multiple channels, maybe single channel, I don't know. And then you just end up with, and there is a technique called event storming or event modeling, where you want to go through the process as the end customer and what do they experience. And then when you actually draw the journey itself, you're just drawing, maybe explain just a bit of the modeling language. Generally, you have commands, you have events, you have read models, and aggregate is just an aggregate of entities. And bounded context is a context in which words have a meaning or some specific meaning. For example, if I will talk about product, if I'm talking to the marketing guy, means entity with 5 attributes. But if I will talk to the salespeople, sales department, the same word product actually means 100 attributes. And if I will talk to the reporting people or to the financial department or to other department, everyone will talk product, but everyone actually imagines something completely else behind the word. That's the problem number one you have to actually think about. And then basically the bounded context is creating context within words have a specific meaning. Therefore, you are creating something which is called ubiquitous language. And then basically you are creating a map that, I don't know, as part of the packet order creation, I have some commands, I have some data, and I have some events. So what I would do, first I would go through the monolith, I would try to distill the context, then you have to find out what is, and each context can have 3 subdomains. There is a core subdomain that says this is our core business. This is business differentiation is very high, and maybe the complexity of the problem being described is very high. So that's the core of your solution. Then you have some and you typically want to have your best developers or best architects to be moving within this area. Then you have some supporting context. So let's say your core business and what is making you very different from the competition is that you have some AI ML driven scoring system. But for that system to work, you need to feed it with data, because otherwise it has nothing to work on. But the data feeding part, that's not your core business. It is supporting subdomain. It has to be there, but it's not the core. And then you have generic one. That's something that actually it's a commodity on the market. Everyone has that. So it's better not to develop it at all. You should rather buy or use some open source or whatever, but you should identify these. There is a really nice guy, Nick Tune, who has a ton of articles on this topic. And basically, after distilling these bounded contexts, I want to have them in a single repo, and is the how to say that, my own developers obey some rules that they are programming against interfaces? Or are they just, will they actually copy and paste pieces of code and integrate in a nonsensical way, and they will just not obey any kind of rules of proper software architecture? So then it's better to just tear it apart on to multiple repos. But to tear it apart, you should actually take a look on another aspect, which is called cohesion. Because if you will tear apart to individual microservices functionality that from the business perspective it has high cohesion, you will end up with a lot of integration calls, and you will end up with a lot of changes that are always impacting both of the microservices. So then the decoupling is not really good idea. You can always decouple on even within the solution. Maybe I can show you example. This is sample application. It's a monolithic application where inside I have 4 or 5 business bounded contexts. One is taking care of accounts, the other one is taking care of customers, the other one of payments, security, and each of them has some structure. So I have a domain part nicely separated from Edge API, from infrastructure part. And if anyone wants to actually communicate with customers domain, they can integrate on domain event basis, and they can follow reactive architecture and event-driven architecture. The fact that this event will be delivered by in-memory event bus or in-memory broker rather than Kafka, that's for the moment. But from the architecture standpoint, you will be ready that in future you can actually tear it apart. Just please don't do the thing that you will make the cuts to individual microservices on a technological basis. There has to be a business reason to decouple that. To draw a map like this, it took us 4 hours to come up with this. And suddenly it was very visible that I have multiple teams delivering multiple features, and all those teams can be independent, they can deliver to production independently, and therefore it makes no sense to share the source code, because at the end of the day, the deployable artifact has to be different. Does that answer the question?
Yeah, definitely. Thanks a lot.
I have one question. You mentioned that you don't want to share the code between each individual teams, but in that example you showed a few bounded contexts being in one application.
Mm-hmm.
Is it was the work in progress, the initial separation before moving to microservices?
Yes, generally you can have either microservice first or monolith first approach. So the question is which one you will take. Sometimes the problem is not clearly understandable, and you want to spend more time discussing with your business people. And as I said, because you want to be able to cope with the speed of the customer experience design, you don't want to be solving integration problems, for example, because if you will tear the microservices apart, suddenly you are integrating, and you rely on integration infrastructure, and you rely on some API exposure, and you have some provider and some consumer to the client. Then you are solving a lot of technological problems, and at certain point in time, it may not make too much sense because it's too early. If you are still in the phase where you are actually finding out about the problem, what is being delivered, then monolith first is a good idea. It is good idea to start with the monolith if you have a team that knows that in future they will be cutting that thing into the smaller pieces as the problem will become more complicated and larger. So this particular example I was showing, that was from the time that we did POC on new mobile banking, and the reason for that code was there to actually teach other teams within the bank how the DDD framework works, how actually the automation works, and that code will never make it to production. Yeah, it is just a POC kind of code. It was just an experiment to show how cheap it is to experiment on a platform and how to actually talk about common ideas while it implements a business problem that everyone is talking about.
Okay, thank you.
Okay. So if that is everything, thank you very much for listening, and yeah, hopefully see you for some other time.